Hello everyone, my name is Kehrer-simpson. I'm a GIS student with Fleming College. My term project is named Urban Forest Canopy and Land Use for the region of Peel. And today I'm going to show you my rule set in eCognition for land use classification of satellite imagery. My partners include Melissa Busk and Prim Doss. So this is the eCognition window. And the first thing we're going to do is we're going to go and open up a new project. And the project would just be whatever image you are working on. So I'm just going to pick one really quickly here. One for my study area, which was C2 or 2 here. And what you'll see is you can name your project here. And first thing I'm going to do is I'm going to relabel my bandwidths to the proper names. Okay, and once you know that whatever bands you are working with, you can usually find out from your satellite image in our catalog. I just like to rename mine so I know what I'm working with. So you'll just click OK, and your image is brought into your window here. First thing I like to do is go up to Window, go split vertically or horizontally, whatever you prefer, and go side by side. And what this does is that whenever you zoom in, you get the window beside it to follow you. So as you can see, this is my rule set here for my image classification. And below here is my image object information window, my classes that I'm going to be classifying this image into each different language classification. So the first thing you want to do is you want to create your segmentation algorithm. So what we did here is we used a multi-resolution segmentation. We set the shape to 0.2, compactness 0.5, and the scale parameter at 100. If your scale parameter is too big, it's too general. Your object's too general. Another thing that you can do is you can have a layer weight. So we wanted to use near infrared for much of our analysis, so we put a little bit more weight on our near infrared band. So I'm just going to run this, and it usually takes about 2 or 3 minutes. Okay, now that we've run that algorithm, as you can see in both images here, it's turned it all blue. These are actually all of the objects that we set for each parameter. So what I like to do usually is I like to have one that just has a nice clear video or picture, and the other one that shows a lot of our objects. Next, what we want to do is we want to run a spectral difference segmentation. So basically what it does is that any objects highlighted in red, and we'll group those together to make the same one object. So I'm just going to execute this bad boy. So now that you've created all your objects from your image, what you want to do now is find threshold values for whatever classification you're looking for. And an easy way to do that visually is to go into your feature view window, go into your object features, layer values, and click on your mean near infrared value if we're trying to find water. And what you're going to see is that the image here has changed completely. So what you want to do is you want to go and you want to check box this little guy in the corner, go to your band, go update range, and what it's going to do is that it's going to show you the minimum and maximum value for your near infrared bands. So what you want to do is you want to slowly click your values here, and what you're going to notice is that water features start to turn black because they no longer fit in between this range here. So that's how I set my water extract value of less than 550. So when I run my water extract, it turns all of the water features in my image to the correct classification. So just analyzing my image here, although these ponds have been labeled as water, there has been some misclassifications, such as the little shadow here, and I believe this is a car. So the next thing that we do is we want to merge our objects that have been classified as water. So now this makes this one big unit, that makes with that one big unit. And the trick here is that we want to say any values that have an area of less than 2,000 pixels to change it back to unclassified. And this increases your accuracy because the wrong things are not being classified as water. And as you can see, what was once labeled as water has changed back to being unclassified. Now that we've created our water classification values from the image, what we're going to do now is classify all the buildings. And to do that, we had to go into our assign class algorithm, and we went down to our conditions, and you might recognize a few of these, but the two biggest being visual brightness, the BAI building spectral indice, and the NDVI veg classification spectral indice. To build those, what we have to do is we have to go down to our feature view, go to object features, customize, and we actually had to go create new. Now, just to show you what values will come up with the NDVI, anything that's not vegetation is darker values. So if we zoom into some trees here, and I go window side by side, you'll see that the trees have a very high NDVI spectral reflectance. Now if we go to our indice over here and we go edit, this is how we built it. So we went the mean near infrared value minus the mean red band divided by the mean red band plus the mean near infrared band. And that's how you get your NDVI spectral reflectance. So we're now going to run our buildings, and we will see how that goes. And as you can see, many of the buildings here were classified correctly. There are a few variances just because some roofs do not fall in there, but we will take care of that in our cleanup stage. The next one that we're going to classify is our roads. So here are our conditions. Similarly, the veg classification has to be less than 0.3 because there's no trees involved, and there's our ruleset there. So I'm just going to execute this, and as you can see, many of the roads were classified correctly. If you ever want to, you can go down into an area and reclassify it by going to View, Toolbars, Manual Editing, and what you can do is you can pick your class that you want to edit. You can go here and simply manually edit whatever object you have to. And like I said, some buildings simply do not fall into the average. There's always outliers with any real thing in the world. So there's going to be a little bit of manual editing. Next, for the forest, we did our rule sets here for classifying the trees, and this should run okay. And as you can see, it does a very good job of picking up even the small individual trees, small individual trees in the fields. So it worked out pretty good. Next, we're going to classify all the grass and shrubland, and as you can see, this can be tricky because some farm fields have vegetation on them and some are in bare fields. So what we did for that is we then go into our merge, we merge all of our grassland, and because in this image we have more bare fields agriculture, what we're going to say is any areas that are bigger than any areas that are bigger than any areas bigger than 500,000 could be sorry, 600,000 could be classified as agriculture. So, for example, down here, all these areas are smaller than 600,000, so that will get left alone and not be classified as agriculture. And the nice thing about this is if you start out big, you can always work your way down. So, that looks pretty good. And if you keep going down, you can always create your classes, and I'll show you what the finished product looks like. So now that we have our forests and roads and agriculture classified, we now have a cleanup stage. And the cleanup stage is to classify anything that didn't meet into our classes. So shadows, any rooftops that didn't had a different spectral value. And we do this just to create a cleaner and more accurate image or classification. So in my cleanup stage here, I have a unclassified, and basically what we're going to do is we're going to execute that, and it says that there's none left here, but I can see it because I just ran it, sorry, before I ran here, and it's classifying anything as red. So if I go back to my image here, it appears that some of these have been misclassified. So for example, this patch of dirt here was unlabeled because it didn't fall into the correct any categories that we had specified, and there's a little bit of patch of dirt here that's been labeled as highway. So what we do here to clean up our image is we will go and we can manually edit, like I said before. So we could say, well, I want to classify this as bare earth. I will use this tool right here, and there you go. Another way of doing this, let's say down here, so we know that there's no grassland here. So what we could say is that, for example, right here, there's no grassland here. What we could say is we could go down to my cleanup stage here, and we could say any grassland that has a border of agriculture. So I changed my grassland there. My grassland has a relative border to agriculture of greater than 90%. We are now going to call that agriculture. So let's see what happens when I run this. So once you have your image classified and you have done your editing stage or your cleanup stage, the last stage is to run your export to vector layer. So what you want to do here is you want to go into name it whatever you want, where you want to save it to, and whatever attributes you'd like to save with that shapefile. So for example, we want the area and the class name. So it'll be as a string, and we will export this, and I can open it up into ArcMap as for an example. So once exported, this is the tile that I was just classifying, and this is ArcMap. I can go right click, open up my attribute table, I have my class name, my area, and my shape. So I'm now able to work with this in ArcMap and use any spatial or statistical analysis that ArcMap has to offer. Overall, this is a great program for land classification using satellite imagery. It's very easy to work with, and I would strongly suggest using this for any image classification. Thank you very much, and have a great day.